Okay, so I'm going to start off just by writing this system of equations as an augmented matrix. I'm going to speed up my writing pretty quick and just throw it in here. And like I said, our goal is to get that triangular system. So really we want to clear out these three values. If we can get those three values to be zeros, then I'll have what my z is down here, what my x and y would be up here, and then I can throw it in for my three variables. So remember, the left side is our coefficient matrix. That's really what we have for x, y, and z. So we can get those to zeros by adding any rows, multiplying rows, things like that. So a good first step I see is if we add these first two rows together, that 1 and the -1 will cancel. So I'm going to do that for my next step. When we use matrices, or what's called Gaussian elimination, and it's this guy, his last name was Gauss, pretty much came up with this method, so he got to name it after himself. On the left side, when we do, we're going to keep track of what our row operations are, we call them. So I'm adding row 1 to row 2, just in case I made a silly mistake. I can go back and see what my goal was. Now you only change one of the rows. I'm not going to change both of them because I want to keep all the variables there. What we're doing, since all these are equivalent statements, right? Every equation's equal. It's pretty much like adding 1, right, to an equation on both sides. So I can just change one at a time. So I'm going to leave my first row the same. If I add the first to the second, I would get 1 and -1. This is 0. -1 and 2 is 1. -1, -3 is -4. And we do the same thing with the answers. So my 7 to -12 would be a -5. All right, so remember to pause me if you need. You can rewind, go back. So that was my first thing. All right, so we want to keep trying to get our zeros here. So now I'm going to aim to get a 0 in my bottom left value, that 3. It's really nice when you have a 1 above it, so up top, because I can use that, multiply 1 by 3, and add or subtract. So what I mean by that is I can take -3 times row 1, so it'll give me a -3 up there, and then I can add it to the third row. Again, I'm only changing the third row because I already have those nice values, right? I've got a 0 here already. I just want to get a 0 down bottom. And all of these equations are, both sides are the same. So again, it's just like adding 1 or adding something equivalent to both sides. So my first two rows are going to stay the same. I've got my 1, -1, -1, 7, 0, 1, -4, -5. Now I'm going to carefully multiply the -1 times row 1. So this would be a -3 plus my bottom row. That'd be 0. That's exactly what we wanted. And we'll go through. So same thing to the second value, right? So -3 times -1 is 3 plus -2 from that bottom row would give me a 1 down here. -3 times -1 is 3 plus 7, that gives me 10. -3 times 7, -21 plus 30 gives me a 9. All right, so we have my two zeros on the left side. Now we want this guy to be a 0, so we're in that triangular form. So I'm going to do the same thing. Since we have a 1 this time in the row above it, so right here, I'm going to use that 1 and essentially subtract these two guys. Probably wouldn't want to use the first row because that'll change my first value. If you guys see what I mean. We're going to do a lot more practice of these next time, so we can go through together. All right. So like I said, I want to get that third row, second column, this place. I want to get that to be a 0. So I'm going to do, I like to always add, so I'm going to say negative row 2 plus row 3. My other rows are going to stay the same. All right, and we kind of see on the left side what's going to happen, but I'm following through on the right here. So I'm going to write in my other rows. And then add. So my first two stay 0, which is what we want. 1 or a -1 plus 1, that's a 0. That's what we wanted there. I'd have a 4 plus 10, 14, and a 5 plus 9, 14. So this is great. I have that triangular form we were looking for. So we have one variable on the bottom, 2 in the middle, 3 on the top. I could just solve this system here, but a really quick last step and something that we want to recognize we could do is I could take our last row and divide it by 14. And we'll see on our next step that row echelon form, we say the beginning of each row, the first number should be a 1. Makes our lives a lot easier when we're solving. Oh, and this guy should be a 1. So there we go. So now I can solve. I've got z equals 14. This second row would be y minus 4z. So it would be y minus 4. Oh gosh, and I put 14 before. That should be a z equals 1. Let's go back and change that. So z equals 1. I'd have y minus 4z equals -5. If I put a 1 in there, it's y minus 4 equals -5. So that would give me a y equals -1. Hopefully I didn't do anything silly. And then I can use these for my top equation. So I'd have an x minus y minus z equals 7. So x minus 1 plus 1 equals 7. So I believe that's our x equals 7. I think this was the system I gave us on the page before. Nope, a little different. But again, we can put those in any equation and check them. All right. Okay, guys, so that's just an example of solving a system of equations using matrices with what we call Gaussian elimination. We'll go in a little more detail next class, but just an intro for you. So you can try out that next example down there involving row echelon form, and I'll see you in class.